Here we are, continuing with our topic that's in the angle properties of a circle. Right, before I take you through, please remember to follow us in the videos. The previous videos can be watched through the link that is in the description down here. So in case you're joining us, can you please do so that the logic should be attached in your minds that way. Right, you are all welcome. Right, so it's just a continuation of what we started. Remember what we are discussing here is about the properties of the circle, tools that can be used to solve problems related to the circle. We discussed the first one, but the angle at the center is twice angle at the circumference. You know how that one it works, right? So be able again to prove the theory as such. Secondly, we discuss about the angles subtended by the same arc or chord, that's are equal at the circumference of the circle, that in the same segment, the previous videos will be able to show you that. And then thirdly, we also discuss about the angles which are subtended by diameter in the same circle that is now on the circumference of which is the right angle. So that's what we had, and the examples attached to at least make us understand how they can be used in solving the problem were done. What do we have today? We are going to discuss the fourth property. This one is about the equal arcs or equal chords. Right. So we have the chords and arcs which are equal. We allow them to subtend an angle at the circumference, and we're going there to find out the relationship between the angles which are subtended by the same or equal arcs. The same, we can also talk of the equal chords. Right, look at my diagram here in this chart. Right, so what we're discussing here, when we talk of angles subtended by the same arc or chord, we are referring to a shape which is like this here, where we have a circle, and the circle have got the arcs that is parts of the circumference. Like if we were to describe the arcs of the circle, we talk of arc AB, arc BX, arc XY, arc YD, arc DM. And what have you? You can even jump one letter, have got arc AY. Right. So the rated arcs will have what? The chords to it, related to it. Like for example here, if I talk of arc AB, arc AB can have a rated chord which is just like when you join A and B, you have got a chord AB. So when we are talking of arc AB, we are also referring to the chord AB. And here again, if we talk of arc XY, we are having arc XY, and when we join X and Y by a straight line, you'll be able to observe that we have got the chord XY. So everything I'll talk about XY, it will be the same about chord XY. And here, whatever I'll talk about AB will be the same as chord what? AB. Right. Now, here what we're doing is this. We given that a circle has got equal arcs and the subtending angle of the circumference. What is the relationship of those angles? So here, let's take it that way, that your circle, remember what I said that time. When we're discussing the geometrical part, you at least need to have the materials. The most important materials, as I said, we need a protractor and also what? A pair of the compass. So what here we are trying to emphasize is like when you take a pair of the compass and you construct a circle like this one here, and then identify, let's say maybe two equal arcs. Like here we have got arc AB and also arc XY. Let's take that XY is equal to arc what? AB. You can not just define the length of this arc and the length of that arc. Now, if we allow this arc AB and arc XY to subtend angles on the circumference of the circle, we'll have a situation like this. Look, X and Y. Remember how I demonstrated how an arc is subtending an angle on the circumference. You can just use the points as of which and let them produce a line that have to meet at the circumference. So if I've got arc XY in this case, I'll use X and Y to go like this. Look at what I do here. Follow those lines and they'll meet at M. So we say that arc XY has subtended an angle at M. In this case, we talk of this angle here. Right. And then if we take an arc AB, this one will have points A and B. We go by those lines up to the circumference of the second diameter D. So at D, it means that this arc here, as you can see, is opposite to angle at D. Then we say arc AB has subtended an angle at what? At D. Right. So if you talk of the related chords of those arcs, the way I was talking of the arc XY, it is as good as mentioning chord XY. Right? And the way I was talking of arc AB is as good as talking of chord AB. So here what happens is this. If arc XY is equal to arc XY is equal to arc AB, then that would also mean chord XY is equal to chord what? AB. So which means that, like, when I say arc XY is subtending an angle at M, then it will mean that chord XY subtend angle at M. Here I also talk of arc AB subtending angle at D. It means chord AB is also subtending angle at D. So what will happen is just like if we do an activity of measuring the angles which have been subtended at the circumference here at M and D by these two arcs, we'll be able to see that you do better when you take your time on your paper and try to measure this angle here by the use of the what? Protractor. Right. So what you identify, you'll be like, you're going to discover that, say, this angle here and this angle will always be the same. They will never be different. Right. So if you measure the value of this angle in degrees, this one maybe is X, you also find that this angle here will also be what? X. So we'd say this is X1, this is X what? X2. Right. So if you do that activity, you're going to appreciate that. So we also going to regard that one as another property of the what? Of the circle. Right. So this one will be true for all arcs which are equal and all chords which are equal. If those chords and arcs are subtending angles on the circumference of the circle, expect that those angles should be always equal to each other. Right. Now, let us now see the areas where we can apply this knowledge now. Next, it will be an example of where we can see how best we can apply knowledge about the angles subtended by the same arc and the chord. Right. Now, let us have an example here. Right. In the example, we are given a circle, center O. This one, O, is a circle here with center O, where we are told that arc UVW, which is this arc here, UVW, we are talking of this arc here, they're saying that is equal to arc WXY. In this case, we talk of arc WXY. So we are referring to this arc here, UVW, and arc WXY. So these two arcs here. Right. Secondly, we are also given that chord WX, this one is equal to chord XY, which is this one here. Right. And angle UYW is 40 degrees. Right. Now, what are the questions? Here we are asked to find the value of the following. One, we are asked to find the value of angle, that's say WY. B, we need to find the value of angle that is WUX. C, find the value of angle XWY. And lastly, that is D, we are going to find the value of angle YXW. Right. So my students, what I said that time, remember that though we may be introducing the property for a circle, it doesn't mean when we give you an example, it means that you are going to stick to one property. No, That's not the way geometry works. Right, that will be just like an opening key to what you need to do. So here we have a problem here, and we have just discussed something about the angles subtended by the equal axis. So still more, you still more supposed to be attached to the previous properties and any other properties that we have learned in the past. Right, you don't just have to stick to only one, so that the question can be well solved. Right, here now we are. We'd like to find the value of angle WUY. WUY in this case is this one, WUY. We are referring to the value of the whole of this angle here. Right, so let's begin with that. If we need to work out the value of angle WUY, you may be able to analyze the question as such, based on the properties which we have just learned. As a student, don't just rush and come in starting solving about it, just think of everything. No. One, you have to first of all come to the question, what am I given? What you are given are the issues that will help you to come and decide the appropriate properties that can help you to what? To find the values of which. Like here now, look at this. I've been told that say chord XY is equal to chord X, chord WX is equal to chord XY. So you are the mathematician, you'll be able to tell by that first to say, mark that this chord is equal to that chord. Then by the property which I've just learned, that the chord subtends equal angles, then we expect that say this angle here should be the same like that angle. Right, so you can first of all fill that information before you really target the question directly. So here, mark that this is equal to this. Then we expect that this WX is subtending angle here, and that angle I can refer it as X1, right? And again, this XY is subtending an angle at that. So since this chord is equal to that chord by the theorem which we have just learned, then I expect this one again to be X. Right, so this one will be X2. Right, so at the end, it'll be like the whole of this angle here, the whole of this angle here, it's just like what? 2x. Right. So now, if I go further, I'll be able to see that by the property of if you can get the properties of the previous videos, you'll find that this angle here, this angle is subtended now by the entire arc, which is WY. And at the same time, WY is also subtending this angle here. So, which means that though we have said that the whole of this one is 2y, the fact that this angle is subtended by the WY, and this the same WY is also subtending an angle here. So you may apply that property we learned in the past about the angle subtended by the same angle are what? Equal. Then we expect that this angle also should be what? X, what? Let me just write this one like what? 2x as such, because this plus this is 2x already. So you bet that x plus 1, x plus x is the same as this one here. So here x plus x is 2x, so this one should also be 2x. We are taking for this arc subtending an angle at u, the same arc is subtending an angle at z. So if this one is x plus x, then this one should also be x plus x. So in short, we just write what? 2x. Right. Then from there, what else do we have? You also observed that here we have been told that say arc UVW, this arc here, UVW, is equal to arc WXY, WXY. So our expectations are also like the same. That say, this arc here, look at this one, is subtending an angle at this point here, which is 40 degrees, right? And also by the virtue of the same property, angle subtended by the same arc, as we observed here, this arc is subtending angle at u, the whole of this one is 2x, is equal to the whole of this one 2x, because of this one. We also see that this was also is also true. by this by the same property. If you look at UW is subtending an angle here, which is 40 degrees, you'll be able to see that, say, the same UVW is also subtending an angle here. So it means if this angle is 40, we should also expect this one to be what? 40 what? Degrees. Angle is also what? Subtended by the same what? Arc. In this case, we're talking of this arc UVW is subtending this angle here. And the same UVW is also subtending angle there. So if this is 40, this is 40. This is 2x, that again is what? 2x. But now, our aim is to work out on this question here. Angle WUY. Now, angle WUY is this one here. More like 2x. So it's more just like we need to just find the value over 2x. The expression 2x is represented by what? Now, having filled up the notations in that diagram by the x, now you come in as a student. Now it'd be like, how can I then find the exact value of this angle here? I've indicated this 40, that is 40, 2x, things like that. But now what is the value of u, sort of w, u, y? Right. So you sit down here and try again to analyze the question. Where do I go? You'd find that if you are very patient enough, you'll be able to see that we are given here that this arc here, look at this one. This arc is the same as this arc. So it is just like this arc is subtending angle, which we said is this 2x. And again, this arc here is also subtending angle here, which is 40 degrees. Now, from what we've just discussed, if I've got arcs which are equal, the subtending angle at the circumference, we expect those angles to be equal. Then definitely it means that this angle here, 40 degrees, is the same as what? 2x. Why is this one equal to this one? I repeat, there's an arc that is subtending those angles that are equal. This arc is equal to this arc. This arc is subtending an angle which we have said is now 2x by notations. And this arc is subtending this angle here, which is 40 degrees. So this arc is equal to this one. We are given here. So what do you expect about that? Then it means if this one is 2x, this one is 40, then 40 is equal to what? 2x. So it's just a matter of forming an equation there. 2x is equal to what? 40 degrees. And then find the value of x as such. But now in this case, you are not even interested to even define by that one. Just say the whole of this angle here is equal to what? 40 degrees by this one here. Right. So if maybe you'd like to find the value of x around there, just divide by 2. It goes. Right. So what it means here, angle WUY from this discussion here, talk of angle WUY is equal to angle UZW, which is 40 degrees. Reasons, angle subtended by the same arc. Right. So that angle should be 40 degrees. So this is what I'll write here for you to say that we talk of angle for A. First, what you write is just like you state here that say angle UYW. Follow me this way. UYW is equal to angle UZ what? W. Angle UZW. Reason. Angles subtended by same arc. Right. That's the way we begin, by answering that. You go step by step. This angle is equal to that angle, 40 degrees. Right. Then you go this way. Once you have indicated that this one is equal to this one, you also have to state that, say, angle that is talk of this one here, that is WUY, which is subtended by what? This arc, W, that's a XY, is equal to angle WZY. So you write here this way to say, angle right? So maybe as much as you have written the statement here, first to say that this angle, you talk of the angle that say U R Y W, U R Y W is equal to angle U Z W. Here, definitely, you have to indicate the value there as what? 40 degrees. Right. Next, what you do, you also have again to tell us about this, as to say, but what angle that is that's a angle W U Y. Angle W U Y. W U Y is equal to angle what? W talk of what? Z Y. That's it. Angle W Z Y. Why? You going also tell us the angles subtended by same arc. In this case, we are referring to this arc here is subtending this angle, and this arc here is subtending that angle. Right. So that one will give you as what? That is 2x. By the virtue of this one, to say this chord is equal to this chord. So if this one is x, this one again is x. Right? Other things I've just mentioned here. So the whole of this one is 2x, that one is what? 2x. So here I've just didn't need here direct as what? 2x. Right. So you also say, but again, 2x, I'll just mention here again, this angle, the 2x, this one here, this 2x, is equal to 40 degrees. Right. So here we talk about what? This 2x is equal to 40 degrees. I'm referring to this one, that this one is equal to this. Why are we saying so? We are given that this arc here, look at this, I will not write this one down. Arc WXY is obtaining this 2x here, and this angle here, not angle, but now arc UVW is obtaining this angle here. So these arcs are equal. This is 2x, this is 40. But we're told that this one is equal to that. So if this one is 40 from the previous steps up there, then we should expect that this one should be this one here. Right. So here, it'd be like, if you look at this angle here, that is the WUY. It is 2x. It is 2x. It's already 2x. X plus 2. Okay? x1 plus x1. Then what we have written here is just true. Instead of writing 2x, then just substitute for this one here. And write this to say, therefore, since we all know that the 2x is representing the WUY, look at this, WUY, which is 2x. And yet we're saying this one is equal to 40 degrees. Then here is just as good as writing, instead of writing this, we write and say, therefore, angle WUY should be equal to 40 degrees. So that is the answer for the first part. It's just an analyzation. You do this, you talk of that, you talk of that, you talk of that, you move to somewhere else until you arrive at the answer. Somewhere else, we mean you solve other angles which are not even part and parcel of the question, but that's just like a stepping stone to what you want. So here we work out first of all the value of that one, the value of this one. They are there to help us to find the value of the angle which have been asked in the question in that case. Right. So similarly, you can also do what? For B, for C. Right. So now, can we just do only the B? For the C and the D, I think I'll leave you as an exercise so that I will also see you be able to apply the knowledge logically, okay? Like using the properties of the circle, and at the end, you arrive at the answer. You see what I've done here? I'm talking of this, then coming back, I'm going there, like that, coming up with the idea, so that at the end, I have to come up with the conclusion that say what I want, that is WUY is equal to 40 degrees. Right. So let us just solve question B, and the C and D will be left as an exercise. Right. Now, For question B, we are asked to find the value of WUX. You come to the diagram here. WUX. So now, since we have already done a lot of things in the area, you analyze the question very well. You have already put everything inside there. I think so, this time around you can even take much time to work out on that one. Here you want WUX. So you have already said that this angle here is equal to this one. Why? The angle subtended by the what? Equal chords. This chord is equal to this one. So if this one is X, this one again is X. Yet we have deduced up here to say the whole of this angle here is what? 40 degrees. So here, if we are to find the value of WUX, it's just like this angle should just be divided by what? 2. You divide the 40 by 2 as such. Then if I have this one as 20, that one again what? It's 20 degrees. Right. So what you write here, maybe because you know what? When you have an idea, the examiner does not know that you know it. So you better write in the sense that say somebody can be able to follow you. You have the information. Now we put it down here. It has to be somehow logical. Right. So I've analyzed that this angle here is the half the entire angle. How do you write it? So first you write this way to say that look at this angle WUX, angle talk of WUX. First of all, say light is angle what? XUY. XUY. Why? You talk of the angles subtended by same arc. Or talk of what? A chord. Right. Now, but look at this one. Now, write this one. But angle that is a WUY is equal to summation of the two WUX plus C angle XUY. This plus this one give you one angle. Therefore, what? The angle which have been asked here, WUX should be equal to what? Half of what? This angle here, which is the angle WUY. Right. The two angles are equal, but the two angles when they're added, they give you one angle. So this needs just to be substituted. Half times what? WUY, which we earlier have found it as what? 40 degrees. So it means here, instead of writing this one, I'll write what? 40 degrees. So I'll just divide here, 2 here, 1, 2 here, what? 20. It means the value of that is what? 20 degrees as such. Right, so simple in understanding and also very easy for you to come up with the ideas about which property can I use to work on that one. Right, so try to write and practice in attempt to find the value of angle that is the XWY. In this case, talk of XWY. Moreover, I think it not even take time for that one. And then YXW, that's the YXW. Here we are looking for the whole oval, this angle here. What will be the value of that one? Right. So students, thank you very much for being together when we are discussing this property that talks about the angles subtended by the same arc are equal. So this was just like an area whereby you can be able to see how best we apply that knowledge here in order to come up with a solution related to the psychogeometry, where we're giving maybe the chords are equal, arcs are equal, right? So this is the way we do. Right, so as of now, let us stop here in the video. We still will be together in the next, where we are going to discuss about the last two properties of this topic. These are properties which are related to what we call the cyclic quadratum. So first I will introduce you into what we mean when you say a quadratic cyclic, then we discuss only two properties of which. Right, so I also still encourage you, please, can you follow the link down here so that you have to watch all the videos and be logical in your brain, right, so that you should not have a gap in your mind. Thank you very much for that.